The mining industry plays a crucial role in the global economy and has a significant impact on our daily lives.
It provides essential raw materials, creates jobs and drives economic growth, supports renewable energy technologies, contributes to technological innovation, and supports sustainable development.
Construction, electronics, transportation, energy, and agriculture are just a few of the businesses that depend on the mining industry for the extraction and production of vital raw materials. Many of the goods and technologies on which we rely wouldn't exist without these raw resources.
In many nations around the world, the mining sector fosters economic growth and job possibilities. Mining corporations support local businesses, pay taxes, and invest in local infrastructure, all of which contribute to the development of local economies. Solar panels, wind turbines, and electric vehicle batteries are just a few examples of the renewable energy technology that the mining industry is instrumental in creating and manufacturing. A variety of metals and minerals that are mined are needed for these technologies. The mining sector fosters technical advancement and is continually changing. For instance, improvements in processing methods have made it possible to recover metals and minerals from low-grade ores, while new mining technology have made it possible to uncover and extract previously inaccessible resources. Numerous mining firms are dedicated to sustainable development and take initiatives to lessen their environmental impact, assist local people, and foster social responsibility. This entails putting into practice ethical mining methods, cutting greenhouse gas emissions, and funding projects for renewable energy and water conservation.
But behind this succession of mining that gave to the world is a problem that costs the environment and nearby communities. One of the significant environmental problems associated with mining is the generation of large amounts of acid mine drainage. The mining industry is the biggest driver of ecological issues. Tailings and excessive exposure to air and water causes AMD. Acids are produced when pyrite and other sulfide minerals oxidize in the presence of oxidizing agents. Undeniably, acid mine drainage is a severe environmental problem in the area of metal and mining industries throughout the world. According to the study of Anusha Vishwakarma et al., AMD becomes a pollutant for the surface and groundwater due to its highly acidic nature and high toxicity. From mineral exploration to the closing stage, mining methods, both open cast as well as underground, have severe environmental impacts with large-scale consequences. In this dilemma, it needs to find a solution. It is evidently proven that there are many neutralizers that has been invented. Like limestone, it is effective as a neutralizer for acid mine drainage. But the cost and availability of limestone can vary depending on the location and the quality of the material. In some cases, transportation costs can be high, making limestone a less cost-effective option for treating AMD in certain areas. Other types of shell, like oyster shell, can also be an alternative neutralizer, but due to its cleaning process of removing salt using large amounts of fresh water, is an additional cost and use of manpower. As future mining engineers, we devised a cost-efficient, environmentally friendly, and economically suitable solution for the mining industry and neighboring communities. Unknowingly, a bewitching gift from Mother Nature that we call an EG will provide a life-changing solution to the world of mining. This freshwater creature is abundant in the Lake Mainit municipality of Habonga, province of Agusan del Norte, and sold in its local market in large quantities. Unfortunately, after consuming the edible part, the locals throw it as waste. Hence, an innovator and future mining engineer was encouraged to find a solution to mining problems instead of throwing it in the garbage. Using its shell can be an alternative neutralizer to treat acid mine drainage. Results shows, according to study, shells contains a substance known as calcium carbonate contents which had higher neutralizing capability for AMD. With this, EG shell as neutralizer in acid mine drainage can help solve several problems associated with mining in terms of environmental impact, which also helps to safeguard nearby ecosystems and water supplies. Exercise regulatory compliance to comply with mining requirements and stay out of trouble. Guards reputation and social responsibility by addressing AMD's effects, which can help them keep their good name and social license to operate, and to save cost. utilizing Vivipara angularis neutralizers can lower treatment costs and prevent long-term equipment and infrastructure damage. The objective of this study is to evaluate the feasibility and effectiveness of using Vivipara angularis shells as a low-cost neutralizer for acid mine drainage, to compare the efficacy of neutralization using 200 ml AMD with the Vivipara angularis shell in different mixing ratios, and to determine the effectiveness Vivipara angularis as a neutralizer in acid mine drainage. For this study to succeed, the methodology must be performed accurately. This involves collecting, washing, drying, crushing, sieving and batch sampling. The Vivipara angularis waste shell will be collected at the local market of the municipality of Habonga and anywhere in the household that consumes ghee. The shell will be washed with a sufficient amount of water to remove sand and other impurities. Then the gathered Vivipara angularis will go through drying in 1 day. After that, the dried shells will be crushed and sieved into particles size of 200 mesh. The acid mine water sample is from the gold ore mining area in Felex Mining Corporation. It is placed on a 2-liter high-density polyethylene container and sealed with an airtight cap. The acid mine water sample has an HP far below the recommended values, 6 to 9. By the Minister of Environment Decree No. 202/2004 regarding wastewater standard for gold and copper mine activities and/or businesses. Batch experiments were conducted to investigate the treatment efficiency under different mixing ratio. 100 grams, 200 grams, and 300 grams of crushed Vivipara angularis shell is placed in different plastic bottles containing 200 milliliters of acid mine drainage sample, and manually stirred and sealed. Then it is set aside for about 48 hours. The pH raise efficiency was calculated as follows, where Ci and Cf are initial and final concentrations, milligram per liter, in the raw and treated acid mine drainage.